What's up? Today you're gonna learn about the internet. You know, the thing you're using to watch this video. You ask how? Well, we're gonna teach you. Duh. Anyway, before we get into how the internet works or how computer networks communicate, let's take a look at what a computer network actually looks like. Yup, this is it. So in a network, we have two, not one, but at least two, or more interconnected computers. Beyond the physical connection between them though, it helps make a kind of unified architecture thing that makes the transfer and exchange of information seamless. Wow! They're either connected by cables or Wi-Fi. You build a computer network using hardware like routers, switches, access points, and cables, and software like operating systems or business applications. You know what those are. You're smart. Now, a geographic location often defines a computer network. A LAN, or local area network, connects computers to a close geographical proximity, like a classroom. You can't just play on LAN while being halfway around the country, unless your cable is like really, really long, I guess. But that's what a WAN is for. Like a wide area network, it can connect computers in geographically dispersed locations, or so pretty far, I guess. The internet is the largest example of a WAN. It connects billions of computers worldwide. Look at this, internet here, over there, everywhere. Well, actually maybe not everywhere. Sorry. So these computer networks have their own set of communication rules, a specific setup, a way they handle data flow, and of course, the reasons why they exist in the first place. Basically how they roll.
Meow, let's talk about how crucial they are. By the way, hey, I'm Bea. Anyway, I'm talking about business, entertainment, and research. The internet, online searches, email, sharing audio and video, e-commerce, live streaming, they all lean heavily on these networks. It's exactly used for what we're doing right now. Yes, you. I'm talking to you through the screen using a network. How exciting. Now that we've got that covered, we can dig into how these computer networks communicate and transfer data and all that other technical mumbo jumbo stuff. Remember when we've talked about LAN and WAN? Let's expand more on that. Local area networks and the wide area networks. These are the two different types of networks. You've probably heard of them before, and if you haven't, it's 2023, get a life. Please. All the computers that belong in the same network can be connected with a common cable, which is called the Ethernet. Imagine this. When computer A wants to send a message to computer B, the message travels in the cable and goes into every computer in the network. So it's like those two paper cups connected with a string. The ones we made as kids, except it's harder to make and we're not kids anymore. Anyway, it basically allows any number of computers to communicate with each other. When the info has been set, it will arrive in its final destination, where someone can read the message and they probably want to exchange stuff back too. Every computer has a unique MAC address to make it easier for your poor old router. This address makes sure that the physical address of the computer is unique. Otherwise, it wouldn't really know where to actually send the information to. It'd be like shooting ducks with a blindfold on. A device can have multiple MAC addresses. A laptop with both an Ethernet port and built-in Wi-Fi will have two MAC addresses in the system. Every standalone computer has a dedicated address given by their ISP, or Internet Service Provider, or basically the company that provides the user access to the internet. This is the IP, or Internet Protocol. Sounds familiar? It's actually hard to get hacked even if you give it away. The IP address is unique for every computer that is connected to the network, and of course defines them so that the computer can be recognizable. The Internet Protocol helps to send data in the same network. The data is sent with network packets. Every computer has a static IP and a public IP. For more info, we have Mr. Sam Shark.
Thank you for that, Miss Bea. Hello everyone, my name is Sam. So to add more to what Bea said, here's a fun fact. Your computer right now has a private IP dedicated to it. This IP is stored in the router, the box thing with the antennas that comes when you install a new Wi-Fi connection. The router has a routing table which collects all the private IP addresses for mobile phones, laptops, or computers that are connected to this network. In every network you connect, the ISP of the network assigns you a different IP. For example, if you switch to a different Wi-Fi network, your IP will change. So a MAC address is not the same as an IP address. They're not twins, they are siblings. Or cousins. Kind of. They are similar in a sense, but different in practice. So an IP address mainly helps in identifying the connection of a network using which the device is connecting to the network, while MAC address ensures the computer's device's physical location. Either way, both still assist in defining a device uniquely on the internet. So basically, when a computer connects to a network, the network knows which one it is from its IP address. In the network, your computer can talk with other computers that are in the same network. So a client-server network is an internet network that consists of one computer functioning as a server and directing several other computers referred to as clients. Clients can access shared files and information in the serving machine by connecting to the server. This can use a local area network or LAN to connect a device to a server with a local path, while a wide area network or WAN uses the internet to connect devices and servers. WAN networks let you have access to more significant data collections, though these connections may need a lot of security measures. Now none of us wants to get hacked, right? Anyways, the function of client-server networks can include
interacting with temporary and local storage, sending data requests to a server, interfacing between server and users, completing database operations, connecting with other servers, processing user requests, writing files on servers, accessing a server files, querying a database, creating interactive web applications.
a client is either a person or an organization. In the IT world, it's a computer or device that actually uses the service. Client devices include laptops, workstations, IoT devices, and other network-friendly devices. A server in the IT world is a computer that provides access to data and services. Servers are usually physical devices, so cloud computing has made virtual servers more common. So it basically goes like this. First, the client sends the request via a network-enabled device. Then, the network server accepts and processes the user request. Finally, the server delivers the reply to the client. This server model has a kind of request and response pattern. Communications between a client and a server functions through Transmission Control Protocol or TCP. A TCP protocol also keeps a client-server connection until a request is done if the device and server sends messages to each other. To dumb it down, they help sort information units. So the client or server model can be used between programs in one computer. The term refers to a network. It's a convenient way to connect programs in different locations. So hopefully now you get how the internet works, specifically how computers talk to each other. This is where our discussion ends. See ya!